Okay, we begin week 5 of our Business 630 Corporate Finance class, a day late. Today is Wednesday, November 23rd. Family coming for the holidays tends to get me behind schedule, but all is well here in Claremont, California on this cool and crisp evening. To this week, we're completing our 2-week tour of capital budgeting. We're going to concentrate on risk analysis tonight, which is located in both chapters 10 and 11 of your textbook. You have a case due this Sunday, November 27th, which is a spreadsheet, capital budget and risk analysis. We started that spreadsheet and looking at it in our video last week, and we're going to complete that tonight and then have a little update over this weekend in our weekend update. You have a template to do this work in a spreadsheet, and you use that template. I urge you to use it. It makes things a little simpler, and you can complete the work. Next week, we change gears and go and start talking about financial statement analysis, looking at forecasting and how to read financial statements to see how these capital projects we've invested in are doing. Also this weekend in our update video, I will post our case assessment paper, which is due December 18th. And you can begin starting on that because now with the completion of this risk analysis, you have all the pieces ready to do that case paper. But more on that this weekend. Let's take a look of where we stand right now in our Blackboard. Okay, here we are in our Blackboard account, which is after now beginning the second half of our class, is probably becoming very familiar to most of you. And as we stand right now, let's just take a look at our timeline here. We have case number 2 due this Sunday, and then another week off, and then we have case number 3 due on December 11th. That is a PowerPoint format file. So we've done APA, we're doing spreadsheet this week, and we're doing PowerPoint in case number 3. And then this weekend, your course assessment case paper is going to be posted. It is due December 18th. That is in 2 formats, APA and spreadsheet. And then we're winding down the course. There's no final examination in this course. Your course assessment paper is basically your final. So that's where we stand. We're now in week number 5. Couple key things about this week is note our learning assignments for this week. You have case number 2 due on Sunday. Here's the spreadsheet file that we'll be working on tonight and finishing up on tonight. We started this last week in week 4. And here's some introduction to key pages to read in the textbook if you happen to have a textbook, or look at the PowerPoint, and then some update videos about sensitivity and scenario analysis, which we are talking about in this video, and some additional overview of capital budgeting. So lots to look over this Turkey Day weekend. Okay, this is where we completed last week. We completed the case analysis, the beginning analysis of this problem where we have an investment of $1 million and all these variables. We went ahead and completed this and determined the return in dollars, net present value, the return in percent, internal rate of return, the return in ratio, 1.36, and the payback in years, a little bit under 5 years. We determined that the weighted average cost of capital was 9.78%, which is our discount rate used to determine the discounted cash flow. And we're following this order of the capital budgeting process. So that's where we stand right now. Now, the next part of this, which we're talking about tonight, is the risk analysis side of this review. What is this information reliable? Is this plan or is this estimation of this capital project a good estimation? What are the different likelihoods of different things happening, and should we be prepared for those likelihoods? One of the best qualities of a sound, efficient manager is to be ready for changes in budget, changes in strategy, changes in planning, changes in the economy. And there's nothing more that highlights that as in the last 3 years of the pandemic. companies had to overhaul their plan and their strategies due to the relationship of the economy to the health issues around the world. So tonight we're going to be looking at risk analysis, and we're going to be concentrating on two areas. And that's what this tab about is here. And we're going to fill this in this evening because you have to do the same thing in case number 2. The first analysis is called scenario analysis. Scenario analysis takes the base case, which we calculated already with a 25,000 unit projection, and we determined that the NPV of that is $384,719. So there it is right there, $384,719. But here's what something is different. We now, in this analysis, determine the probability of those events occurring. We think it's a 50% probability that we will sell 25,000 units a year for 10 years in this project. That's what we think is going to happen, the probability. Now, if many of you work with companies that have what is called risk management offices, many smaller companies have their public accounting firm take a look at this analysis. Many companies have statisticians and statistics and business statistics people to come up with these probabilities. However they get it, you as the financial manager are given this probability, and then you apply it to what is called the scenario analysis. Let's anticipate that there's now going to be a strong likelihood of a strong economy. That means we're going to sell 35,000 units a year, and there's a 25% chance of that occurring. So we go back to our base case analysis, and this is where setting up your spreadsheet the correct way will make this a lot easier when we do these risk analysis. So all I need to do is go to the units sold and change it to 35,000. And automatically, my numbers change. Automatically, it takes 12% in working capital and calculates the new working capital. Automatically, it calculates the change in sales and the change in variable costs. So not now, if I think there's going to be a 35,000 units sold, a projection of a strong economy in this project, that gives us an NPV of 948,836. And so I put that here, 948,836. And there's a 25% of that occurring, so it's weighted by 25%. Now we also another part of the scenario is what happens we have a weak economy. What happens if we're hit by a recession? What happens if we're hit by another pandemic and we can only sell 12,500 units of product? So let's change this to 12,005. And notice all my numbers change. And look at 12,500 units, I'm losing a negative net present value of 320,426. So we put that here, minus 320,426, and it weights that by 25%. When you're done with that, make sure you go back to your original base case and put in the original amount, 25,000, so it keeps all your numbers nice and clean. And then you go back to that scenario analysis, and here's what you get. By taking the various net present values at the likelihood of 25,000 units sold per year, 35,000 units sold per year, and 12,500 units sold per year, and weight them by the probabilities given, you come up with what is called a weighted NPV scenario. And as you can see, it's not much different than our original base case. But if you weight the likelihood of certain things happening over the next 10 years, we're still making $349,462 in weighted NPV. So this scenario analysis of these scenarios given in this problem don't really change our profitability that much. But here's another reason why you do that. Knowing that, let's say in year 2, all of a sudden you notice sales are starting to drop below 25,000 units a year. You need to know that as you get closer in lower sales per year, you're getting closer to net loss or net NPV loss. And that means you need to make corrections to your strategies, corrections to the program, corrections to the project as the project is going on. And this goes back to your accounting days when you did variance analysis, budget to actual. And with that variance analysis, if you are getting below the numbers of planning, you need to take appropriate actions to take care of that. And that's what this tells you is what's the bottom line of when we start really losing money. It's anywhere between 25,000 and 12,500 units per year. We get closer to 12.5, we know this project is going to be losing and we need to take appropriate actions. But on the whole scenario analysis is taking all the possible NPVs that you've calculated in your case and then weighting them by the probability of those occurring. So that's the scenario analysis. Pretty simple. Now it gets a little bit more complicated when we take a look at sensitivity analysis. Sensitivity analysis is two things. First of all, it takes key variables of your project. These are all the variables of the project, and it takes key variables, in this case, selling price per unit, which in our original base case is $20 a unit. It takes variable cost per unit, which in our original base case is $8 a unit. And it takes fixed cost, which in our base case is $50,000 a unit. So it takes those three variables and then says, what happens if selling price per unit drops 15%? What happens to our NPV? What happens if variable cost drops 10%? What happens to our NPV? What happens if fixed costs go up 15%? What happens to our NPV? So our job here is to independently change these key variables, determine the NPV, and then see how much of a change how sensitive those variables are to change. How much are we going to make or lose if certain things happen to these variables? Variable costs could go up because we sign a new labor contract. Variable costs could go down. We found cheaper materials. Fixed costs could go down. We found a new cheaper place to do business. Selling price could go up. We find that 25,000 units we're selling out all the time. Why don't we be like Apple Computer and raise our selling prices and take advantage of the market really wanting and high demand for our product? So all these determine the sensitivity of how these changes in these three independent variables affect our profitability. And then over here, we chart them. And you'll see this chart develop as we go through this exercise. Now, there's two ways of doing this. The easy way and the more complicated way is to create a table. But I'm not going to do that because that requires a little bit more Excel, matter of fact, a lot more Excel expertise, and I don't want to burden with you guys in setting up the table. So the easier way of doing this, but it takes a little bit longer, is to just go through your base case and one at a time, alter the variables and determine what the NPV is. For example, in our first one, the selling price is $20. What if we lower the selling price 15%? How does that affect our NPV? So I simply go, because remember, I have all the revenue all set in these formulas. So if I go to selling price now and put in equals 20 times 1 or times 0.85. What's 0.85? It's 15% lowering of your selling price. 100% minus 15% is 85%. So I'm going to take 85% of our planned selling price, $20, and I get $17. So now it's taking $17 times 25,000 units, and it's coming up with new revenue numbers. And notice what happens. I lower the selling price by 15% and I don't change anything else. Notice I didn't change variable costs. I didn't change fixed costs. I didn't change taxes. I didn't change anything else. All I changed was the independent variable of selling price, and I get $32,675 net present value. So I'll put that $32,675 right here. Now let's do it for 10% reduction in selling price. So now I go back to that cell and I say $20 times 0.9. That's a 90 or a 10% reduction in selling price. I come up with 18 bucks and now I start making a little bit more money, $150,023. So I put that here. And there we go. And notice some strange things start happening over here. Now with a 5% change in selling price, so we'll make that 0.95, 19 bucks, 267, 371. Okay, 267, 371. And then at a zero change, it's the original NPV of our original base case, 384, 719. So I'll put that there. Notice I must be doing something right because the line is dead straight. If I put in the wrong number here, let's say I put in 0, watch what happens to the line. It gets a little crooked. It gets a little crooked. So I know I did something wrong. So if I go back to where I was before, notice the line straightens out. So you know you're doing this correctly when the graph of this line stays exactly straight. Now let's go to the second half of this sensitivity analysis for selling price per unit and put in a 5% increase in the $20. So now I put in $20 times 1.05. That's 5%. 100% plus 5% is 105%, 1.05. So we're raising our price to $21. Now we're going to start making some more money because we're selling 25,000 units at 21 bucks, 502,067. NPV is the value you use to determine this. Now a 10% increase in selling price, 1.10. 22 bucks. It's easy with $20. 619, 416. See, that's the great thing about setting up your spreadsheets correctly. Just one or two keystrokes and you get your new information. 619, 416. And notice that line. It's growing and it's still straight. Now 15% increase in selling price. $20 times 1.15. 736, 764. And we've just completed the analysis of the sensitivity of different increases or decreases in just independently the selling price per unit. It goes from a low of 32,675 to a high of 736, 764 in dollars NPV. That's a range of $704,089. And here's the range here, all the way to the top. And notice it's nice and consistent. So now we go back to our base case and put everything back to normal again. Let's not increase the selling price at all and keep it $20. And now we're back to our original 384, 719. And now let's adjust variable cost. A second sensitivity variable, $8 a unit. Let's decrease our variable cost at minus 15%. Let's lower our variable cost by 15%. How does that affect the project's NPV with everything else staying the same? So we go to variable costs equals 8 times 0.85. That's 15% reduction in variable costs. And we get, notice sales don't change, everything else doesn't change except variable cost, and we lower our cost by 15%, we make more money, 525,220, and we put that here. So we're going to do the same thing just like we did in selling price, but now adjust variable cost by these deviations and come up with the new NPV, and it's going to start charting over here. But because this is an expense, the line will go this way. Revenue, expense. So let's take a 10% reduction in variable cost. That would be 0.90. We lose some more money. Naturally, we don't have to make as big cuts as variable cost. So it's 478, 386. And now we begin to see the line take shape. So let's take a 5% reduction in variable cost. That's 0.95 times $8. And we make 431,553. 431,553. No change. It's still the 384,719 with no changes. That's our original base case. 384,719. There we go. And now let's increase our variable costs by 5%. Now we're going to probably start losing money because our costs are going up. So a 5% increase in the $8 is $8 times 1.05. And that's right, 337,886. It goes down. A 10% decrease or increase in our variable costs, 1.10. 291,052. We're making less money. And finally, a 15% increase in our variable costs, 1.15. And now it's 244,219. And notice our line, dead straight. Notice the line meets at 384,719 with the revenue line. That's our zero increase. And you can just put the cursor there and you can see that. But now we've determining the risk and sensitivity of changes in our variable cost. And notice from a low point, or excuse me, a high point of 525,220 with a 15% deduction in cost to a 244,219 profit when we've increased it, that's a range of 281,001. And we're beginning to see a pattern. The higher the range from high point to low point with whatever variable means the steeper the slope of the line. 704, notice the steepness of the slope of this line. 281, notice the line is a lot more flatter. Interesting, and we'll summarize this as soon as we get done with the fixed cost. Again, let's go back and make variable cost back to where it was before at $8. And now we're back at our base case. And now let's change fixed cost, $50,000. So $50,000 times 0.85, which is a 15% reduction in our fixed costs. 384,719. Is that right? Let me see here. Excuse me. I didn't do a formula right here. Notice this is something that I made a mistake. Notice I typed in 50,000. I didn't say in the original 50,000 equals this cell here. And now it's changed my formula because instead, remember, we put here in the original year one cells, we put in the actual calculation. And then here, if I put in 50,000 from this cell here, it's now taking a 15% deduction. And then it does the inflation going out based on that original rate. And so now this spreadsheet is correct. So 418,534 if I reduce fixed costs by 15%. 418,534. Off to a slow start there, but we're okay. Now let's reduce our fixed costs by 10%, 50,000 times 0.9. There we go, 407,262. And now our line starts taking shape. A 5% reduction in fixed costs, 0.95, 395,991. There we go. We put in with no change, 384,719. There we go. Okay. Oops, 384,719. There we go. You got to do this kind of slowly because you could make a keystroke error. You could put in the wrong number and then everything gets all out of whack. So you got to go through this fairly slow, especially if you're doing it for the first time. And if you do it slow and deliberate, it'll work out. As long as you can see your lines are nice and straight, no blurbs, you're doing it correctly. Now let's go to a 5% increase in our fixed cost. 1.05, and now we're going to start losing some money. 1.05, that's 373,448. There we go. A 10% increase in fixed costs. Notice we're not changing any other variables. That's why it's called a sensitivity analysis. We're just changing one variable at a time. 362,176. And then finally, a 15% increase in fixed cost. 350,905. And there we go. We're done. Notice this line has a range of only 67,629 top to bottom. And notice the line is even flatter. Now, what does that tell you? Well, it means, and this is common sense really, but it tells us that the most sensitive variable in this analysis naturally is the selling price per unit. We change the selling price per unit, that really affects the profitability of this project. The variable cost and the fixed costs affect it, but not as much. So the most sensitive variable is selling price. Well, that's common sense. But the good thing about this is you now have a template to look at possible changes in the real world as your project develops over the 10 years of its life. What happens if our prices change? What happens if we can sell 25,000 units at a higher price because there's such a high demand? Or what happens, do we have to lower our price by 15% to sell 25,000 units? In order to sell 25,000, people aren't going to pay 20 bucks for it. They're going to pay $18 for it. So these are good strategies or good ways of looking at alternative strategies to the development of this project. And as the project goes forward over the 10 years, if you see trends changing with these sensitivity variables, you can contradict or counteract those changes with increased strategies. Change the way the project is operating. Some of you might have heard of the company SAP, or the company up in, oh my God, I just had a brain freeze, up in Northern California. The software company, darn it. Well, these two companies, Oracle, there we go. Hey, thanks, Rick. Oracle up in Northern California and SAP in Europe. These two companies, this is what their software does for companies. You can download the accounting data or the project data into SAP or Oracle software, and they'll do these analysis for you automatically. A lot of companies buy this software to do these strategies for them. The smaller companies will pay their public accounting firms, consulting part of the public accounting firm, to do these analysis for them. But what it gives them is a template looking into the future. It should changes result in your project and in your investment over time. Changes as a result of changing in volume, units sold, produced, or changes in key variables in the sensitivity analysis. I'm asking you to do this analysis in case number 2, where you do this base case and at the same time do the sensitivity analysis to this base case and change, and how will changes affect the profitability the NPV because of these different scenario or sensitivity changes. So this is a good template on how to do the complete capital budget process, and I will post this to Blackboard in addition to the original file. So what I suggest you do is take a look at this original file when this was blank and try to do it yourself. And then take a look at this solution file and see if you did it correctly the way I did. That'll be a good test, and then you can take that confidence and do the work that's given to you in case number 2. And I'll have a follow-up to this in our weekend video as you complete case number 2, just to make sure you can get the flow of how we're going to be doing that with that specific case. Okay, that's a pretty good introduction to our finishing our work with capital budgeting and risk analysis by looking at that sample file that we just did in that case that we did. And now you'll take that learning and apply it to case number 2 for your assessment work for this week number 5. This is a great video to review for that. Keep it handy, look at it. If you have any questions, please let me know. Remember, there's Thanksgiving is tomorrow, so there's no office or student hours tomorrow night. But if you need questions on Friday or this weekend, I am available. Send me a text, send me an email. If you want to set up a Zoom session, no problem. Just give me some advanced knowledge or advanced information, like an hour or two, and we can set something up. I'm not going anywhere this weekend. Good luck with your case number 2. Hope this helps, and I'll see you back this weekend with our weekend update video. Have a great Thanksgiving and be safe. Until the end of the week, adios.